In 2020, the cost to ship a single container from China to South America spiked by 443%, like almost overnight.
Which is just staggering when you really think about it.
Right. Welcome to the deep dive. We are looking at the massive, intricate machine operating all around you, 24 hours a day, 7 days a week.
It never stops.
Never. It crosses oceans, spans continents, touches almost every single physical object in your life. And when it's working perfectly, you're completely oblivious to it.
Exactly. It's practically invisible.
But the second it breaks, like as we saw with those insane container rates, the whole world notices. So today, we're jumping into a dense but incredibly fascinating stack of APICS certified supply chain professional materials.
Yeah, specifically focusing on Module 5, Section A, which is logistics and distribution.
Right, and the mission today is to shortcut your path to becoming a supply chain master by exploring how goods actually move around the globe.
Oh, wait.
Okay, let's unpack this because that container statistic you mentioned, it just highlights how volatile this all is.
Oh, absolutely. I mean, logistics is really the only supply chain function that never, ever gets a day off. There are no holidays for global trade.
Which sounds exhausting.
It is. And to truly understand this machine, we have to establish one overarching theme right from the jump. Every single decision in logistics, and I mean every single one, is an integrated trade-off between cost minimization and customer service.
So you can't tweak one without directly impacting the other.
Exactly. You pull one lever, another one moves.
Why do we even move things the way we do, though? How do companies figure out the balance between the sheer cost of moving a physical object and, the customer's constant demand for absolute perfection?
Well, it all comes down to what the materials call the logistics value proposition.
The logistics value proposition, correct?
Right. The ultimate goal is to achieve customer satisfaction at the lowest total cost. And that word total, that's the trap. That catches a surprising number of organizations.
How so? Is it cost just cost?
You'd think so, but for decades, you had corporate accounting departments working in strict silos. They were just looking to slash their own specific budgets to look good on paper.
Oh, I see. So everyone's just protecting their own turf.
Precisely. So say a transportation manager might find a much cheaper, slower way to ship raw components to a factory. They save a ton on freight costs and maybe even get a bonus for it.
Right, they look like a hero.
But because that shipping is slower and less reliable, the factory now has to hold massive amounts of safety stock inventory just to ensure they don't run out of parts and stop the assembly line.
So the transport guy wins, but the warehouse guy completely loses.
Exactly. The transportation costs went down, but the inventory holding costs skyrocketed. Or even worse, a cheap shipment is delayed, and the entire manufacturing plant has to shut down for 24 hours.
Wow.
Yeah, so you didn't actually save the company any money. You just shifted a small departmental saving into a massive systemic expense somewhere else.
That makes a lot of sense when you put it that way. I mean, it's exactly like booking a cheap, heavily delayed flight to save $100 on your vacation.
Oh, that's a perfect analogy.
Right. But because your budget airline is delayed and you miss your connection, you end up paying $200 for an extra night in a hotel, plus $50 for terrible airport food.
Yeah, you hyper-focused on the transport costs and completely ignored the total cost of the trip.
Exactly. But figuring out that perfect total cost in a real business sounds nearly impossible. Every customer is going to want next-day delivery if you offer it. How do companies actually measure if they're bleeding their budget dry just trying to provide perfect service?
Well, they have to look at the benefit-cost impact of a logistical failure.
Yeah.
And that completely depends on the customer's reality.
Okay, give me an example.
Sure. Let's say you're shipping a highly specialized custom replacement part to an automotive factory. If that part is missing, their assembly line halts, costing them tens of thousands of dollars a minute.
Oh, wow. Yeah, that's huge.
Right. So in that scenario, it absolutely justifies the massive expense of putting that single 20-pound part on a chartered jet and flying it across the country. The cost of a service failure is catastrophic.
Right, but I'm guessing that logic doesn't apply to everything. A pallet of toilet paper isn't getting a private jet.
Not at all. Imagine you're shipping standard paper towels to a massive retail distribution center. If that delivery is a day late, the retailer just dips slightly into their safety stock.
Nobody even notices.
Exactly. The end consumer shopping in the grocery store has no idea. Paying for premium air freight for paper towels just to be perfect on your delivery time would be a terrible misallocation of resources.
So how do they track all that?
That's why leading supply chain companies have shifted to something called activity-based costing. Instead of just looking at general ledger accounts, they track the exact cost of every specific logistical activity and touch point across the entire system.
It ensures that the service level you provide perfectly matches the economic reality of a failure.
You got it?
But, I mean, achieving this perfect balance of cost and service across a global network, tracking every single touch point, that sounds incredibly difficult to do on your own.
It's nearly impossible for most companies to do alone.
Which brings us to how organizations manage that immense risk. Let's talk about risk pooling and outsourcing, because clearly companies can't build all this infrastructure themselves.
Right. Since the cost of holding safety stock inventory absolutely everywhere is just too high, companies rely heavily on a mathematical concept called risk pooling.
Okay, risk pooling. Break that down for me.
Let's say you have 50 different small warehouses scattered across the country. If you hold inventory locally, an unexpectedly huge order from one single customer in Chicago will completely wipe out the Chicago warehouse's stock.
And then you have an angry customer, or you're paying an absolute fortune to rush ship items from the New York warehouse to cover the gap.
Precisely. But with risk pooling, you consolidate that inventory into one central regional hub. Statistically speaking, this buffers against high variability in demand.
Because it's all in one big pile.
Right. When you pull from a central pool, that same huge order from Chicago is statistically small relative to the total central supply. You drastically reduce the total aggregate inventory you need to hold across the country.
Without increasing the risk of running out of stock.
Exactly, because a spike in Chicago is usually offset by a quiet day in New York.
So you're using the law of large numbers to smooth out the chaos of individual customer demands.
That's exactly it.
But managing that massive central hub and organizing the transport to get things out of it quickly, I mean, that means you need serious help. The sources detail two major types of partners companies turn to 3PLs and 4PLs.
Yes, the logistics providers.
My understanding is a 3PL, or third-party logistics provider, takes over specific physical functions. They own the actual trucks, or they own the physical warehouses. Think of companies like UPS or FedEx.
Correct. They are the asset-based operators executing the physical movement.
But then you have a 4PL, a fourth-party logistics provider, and they don't necessarily own the trucks or the warehouses at all, right?
No, not usually.
They act more like a management layer. They take over the entire logistics operation and subcontract the various 3PLs on the client's behalf. And they usually charge, like, a flat fee for the management rather than marking up the freight costs.
That's spot on. The benefits of both models are significant. By outsourcing, a company gets improved business focus. If you make high-end electronics, you can focus your capital on R&D and manufacturing, while specialists handle the movement.
Makes sense. Let the experts do what they do best.
Exactly. You also gain access to vastly better technology, because a dedicated logistics company is constantly investing millions in routing algorithms and warehouse management software that, frankly, you could never afford to build in-house.
So it's basically like hiring a master plumber to fix your pipes. That's your 3PL.
Yeah.
They're a specialist executing a specific, highly technical task.
Yes, great comparison.
But a 4PL is more like hiring a general contractor to build your entire house. The general contractor brings their own trusted crew of plumbers, electricians, framers, so I can just hand over the blueprints, walk away, and focus on my actual job.
Right, you're buying the management and the integration.
But here's my issue with that. If I cede that much control to a 4PL, isn't that incredibly dangerous? I'm essentially letting an outside contractor be the face of my company to my very own customers.
What's fascinating here is that you've hit on the exact risk that keeps supply chain executives up at night.
Really?
Oh, yeah. The 4PL subcontractor essentially becomes the brand representative of the client company. Think about it. If you order a new laptop and the delivery driver throws the box onto your porch and breaks it, you don't usually call the delivery company to complain.
No, I get mad at the brand I bought the laptop from.
Exactly. The brand takes a reputation hit. Furthermore, there's the strategic risk of losing direct control over your logistics network, or, potentially having confidential sales data leak if your logistics provider is also working closely with your direct competitors.
Oh, man. Yeah, so you can't just hand over the keys and go to the beach.
Exactly. The sources emphasize heavily that outsourcing is an optimization process, not just a minimization process.
Say more about that.
You can't just pick the absolute cheapest 4PL and walk away. You have to ensure they're hiring the most qualified 3PL partners for your specific needs, not just funneling business to their own biased subsidiaries.
Ah, I see.
And you have to set up rigorous performance metrics and service level agreements to ensure the first 6 to 12 months of the transition are deeply managed by your own internal team.
Optimization, not minimization. Okay, so once you've decided who is managing your logistics, you have to figure out where your physical goods are actually going to sit. Let's look at warehousing strategy. The first major choice seems to be ownership models.
Right, and there are three main models outlined here. First, private warehouses. These are owned and operated by the company itself.
Which gives you total control, right?
Yes, total control over the operations. You pay no markup to a landlord, and a massive physical building gives you a strong, prominent market presence. But the trade-off is a massive loss of budgetary flexibility. You have high fixed costs, mortgages, property taxes, maintenance that persist, even if your business takes a sudden downturn.
Right, and a warehouse is a depreciating asset. It's tying up a lot of capital. Then you have public warehouses. These are independent businesses offering pallet space for a fee.
Which gives you incredible flexibility.
Yeah, like if you sell holiday decorations, you can rent a ton of space in October and almost none in February. Plus, you get lower costs through their economies of scale.
Exactly.
Yeah.
And sitting between those two extremes is contract warehousing.
Right, where you sign a longer-term agreement for guaranteed space and tailored services, but you still aren't on the hook for owning the actual real estate.
Exactly. But honestly, deciding on the ownership model is often easier than the geographic strategy.
The geographic strategy, like where to actually put them on a map.
Yes. The more complex strategic decision is deciding exactly how many warehouses you actually need in your network. And the cost trade-offs here are incredibly dynamic.
Walk me through it.
Let's say you have only one central warehouse for the whole country. Your transportation costs to your final customers are going to be very high because the travel distances for every single package are huge.
Sure, shipping from Kansas to New York for every order is going to add up.
So naturally, you start adding more local warehouses closer to the customers. Initially, your total logistics costs go down because your transportation savings are much greater than the cost of leasing the new buildings.
Okay, that makes sense.
But eventually, as you add more and more locations, that total cost curve bottoms out and sweeps right back up.
Wait, if the goods are getting closer and closer to the customer, driving transport costs down, why does the total cost curve suddenly sweep back up?
Because of the crushing weight of redundancies. Think about it. If you have one warehouse, you have one management team, one IT system, one set of forklifts, one security contract. If you expand to 20 warehouses to get closer to the customer, you've just duplicated all of that overhead 20 times.
Oh man, yeah. That adds up fast.
It does. But more importantly, we have to go back to our risk pooling concept. If you decentralize your inventory into 20 small local warehouses, you completely lose the statistical buffer of a central pool. Your aggregate safety stock across the entire system has to increase massively just to prevent local stockouts.
It's the closet space analogy. I've totally noticed this in my own life. If you have one central closet in your house, you actually own less stuff overall because you can easily see everything you have.
Right.
But the second you move into a house with 5 closets scattered around the bedrooms and hallways, human nature takes over. You inevitably end up buying more junk just to fill the empty space, and you duplicate things because you forgot you already had a winter coat sitting in the guest room closet. Adding warehouses inevitably leads to bloated inventory.
That's a perfect way to visualize the corporate reality. You are constantly fighting the bloat, and this tension dictates real-world corporate strategy. Walmart, for example, typically locates its massive distribution centers out in the countryside.
So they are deliberately prioritizing cheap land, lower taxes, and centralized risk pooling to keep their total costs incredibly low.
Exactly. They can do this because they know their end customers are going to drive to the physical retail stores to pick up the goods anyway. Amazon, on the other hand, does the exact opposite. They place fulfillment centers right inside key, highly expensive urban areas.
Because Amazon is explicitly guaranteeing same-day or next-day delivery, the customer is demanding that insane speed, so they have to absorb the high real estate costs.
Precisely. And this requires rigorous system-wide thinking from supply chain managers. You have to seriously ask yourself, do your local customers actually require rapid same-day delivery?
Are they willing to pay for it?
Exactly. Is that an order qualifier, meaning they will flat out refuse to buy from you if you don't offer it? Or are you paying massive overhead for expensive urban warehouses and totally bloated safety stock just to provide a level of speed that your customers don't actually value enough to pay a premium for?
That's a great question to force a company to answer. Okay, so we've placed our warehouses on the map. Now we need to zoom in. Let's look inside the four walls of the warehouse itself. How do companies keep the costs down when moving thousands of items around inside a building?
What the materials detail stock location methods. And the two big ones are fixed location and random location.
Right. Fixed is exactly what it sounds like. Every single item has a permanent, assigned spot on a shelf. It's super easy for human workers to remember where the hammers are, but if you're sold out of hammers, that specific shelf just sits totally empty, wasting expensive space.
Right, which is why modern organizations that prioritize maximizing their storage space use random location storage, which is also known as floating inventory.
Floating inventory.
Yeah. When a pallet of goods arrives off a truck, it isn't taken to a dedicated aisle. It is placed in literally any empty space available in the storage racks at that exact moment.
Here's where it gets really interesting, because to me, random location storage sounds like a nightmare. Yeah. It sounds like a messy teenager's bedroom where you just throw things wherever there's an empty spot on the floor. How does throwing goods into random, unpredictable spots actually make a warehouse more efficient? If I need a hammer, and it could be in one of 10,000 random spots, how is that better?
I get that. And if humans were relying on their memory to find that hammer, it would be a total disaster. Exactly like that teenager's bedroom. You'd spend hours wandering the aisles.
Right.
But the magic here relies entirely on automated tracking and digital locators. The warehouse management system, the WMS, scans the barcode and knows exactly where every single item is placed in three-dimensional space.
So the computer is keeping track of the mess.
Exactly. This maximizes what we call cube utilization, meaning you are using every single cubic foot of vertical and horizontal space efficiently, never leaving an empty gap. When an order comes in, the system calculates the absolute most efficient, zigzagging route through the aisles to grab those randomly placed items in record time.
And speaking of how we grab those items, the sources heavily contrast mechanized systems with fully automated systems.
Right, a very important distinction.
So mechanized systems are your traditional forklifts, tow lines, conveyor belts, things that help move heavy loads but still require a lot of human intervention and driving. But automated systems like robotics and automated storage and retrieval systems take the human out of the travel entirely.
Exactly.
The example of Amazon's Kiva robots in the text is just mind-blowing. Amazon acquired this robotics company, and outfitting a single warehouse cost between $15 and $20 million upfront.
A huge investment.
Yeah, but it cut the click-to-ship cycle time down from 60 or 75 minutes to just 15 minutes.
The efficiency gains of automation like that are staggering.
Yeah.
Because the Kiva robots are low to the ground, they slide under the storage rack, lift the entire rack up, and bring it across the floor to a stationary human worker.
Hold on, I have to interrupt here. If you have hundreds of these robots zooming around a massive warehouse floor, carrying entire shelves with zero human intervention, isn't that just one tiny software glitch away from a massive catastrophic traffic jam? Or what if a robot drops a shelf?
It's a valid fear, and it does require incredibly sophisticated collision avoidance software. But the reality is, robots don't get distracted. They don't take bad corners, and they don't need wide, comfortable lanes to operate safely like a human driving a forklift does.
Oh, so they can pack the shelves closer together?
Exactly. Because you eliminate the need for wide human aisles, those robotic warehouses can physically hold 50% more inventory per square foot. And overall, it cuts operating costs by roughly 20%.
Which is massive at scale.
It equates to savings of close to $22 million per warehouse. It completely changes the concept of velocity in a distribution center.
Wait, when you say velocity, I assume you just mean the conveyor belts are physically moving faster?
Not quite. Velocity in warehousing isn't just raw speed. It's about accessibility. In a poorly designed, mechanized warehouse, you might have to use a forklift to physically move 3 heavy pallets of slow-moving inventory out of the way, just to reach the 1 pallet of fast-moving inventory you actually need for an order.
Ah, I see. That is wasted labor, wasted fuel, and terrible velocity.
Right. Automated systems ensure high-velocity items are always immediately accessible. The system sorts itself constantly during downtime, so the human workers are left to just handle the very final, delicate physical steps of packing the box.
Okay, so the robots bring the shelf to the packer puts the item in a cardboard box, and now that box has to leave the warehouse. This brings us to the final step of the distribution process, getting the goods out into the world. Let's look at transportation strategy. We basically have 4 main modes of transport to choose from, right? Rail, motor, water, and air.
And choosing between them is an evolutionary problem-solving exercise. Each mode has unique capabilities tailored to specific physical and economic realities.
Break those down for me.
Well, rail is highly efficient for incredibly heavy, low-value loads over long distances. Think coal or grain, because it has very low variable costs. Once the train is moving, it's cheap to keep it moving. However, the ride can be very rough on fragile goods.
Makes sense. And motor.
Motor or trucking dominates the logistics landscape because of its unmatched accessibility. A truck can drive directly from a port to almost any retail door on the planet. Water transport is incredibly cheap and highly sustainable, but it is painfully slow and geographically limited to ports and navigable waterways.
Right. And air is the fast one.
Exactly. Air transport offers unbeatable overnight speed, but the variable costs for jet fuel and specialized labor are absolutely astronomical.
The sources also dive into the economics of the journey itself, specifically economies of distance and scale. Basically, longer trips are cheaper per mile than short trips. Like, cruising at a steady speed on a highway uses way less fuel and causes significantly less wear and tear on an engine than the constant starting, stopping, and idling of local city deliveries. The sources also talk about TL versus LTL. Shipping a full truckload is exponentially cheaper per unit than a less than truckload.
That's a crucial point. If you hire a truck to move a single pallet, which is an LTL shipment, you are still paying for that driver's entire daily salary, the commercial insurance, and the fuel to move a 10-ton cab down the highway.
Yeah, the truck doesn't get 90% cheaper to operate just because the trailer is 90% empty.
Exactly. You have to spread those massive fixed costs over a full truckload of goods to achieve efficiency.
Right, but the decision of which mode of transport to use doesn't just come down to what's cheapest. It fundamentally relies on a specific matrix, value density versus packaging density.
Yes. Let's walk through a scenario to explain this. Think about high-end digital cameras or laptops. They have an incredibly high value density. You can fit millions of dollars worth of electronics onto a single, lightweight wooden pallet.
Because they're small and expensive.
Right. Because there is so much capital tied up in those specific boxes, it makes total economic sense to use expensive, fast air transport. You want to get those products into stores and sold so you can recover that invested money as quickly as possible.
But on the flip side, think about bricks. Bricks have a very low value density. A pallet of bricks is incredibly heavy, bulky, and practically worthless compared to its weight.
Exactly.
You absolutely cannot fly bricks on an airplane. The jet fuel would cost 10 times more than the product itself. Bricks have to travel via slow, cheap modes like rail or water.
Right. It's all about the nature of the product.
But speaking of water transport, this blew my mind. The text notes that water transport releases roughly 800% less CO2 per ton mile than trucking.
It's incredibly efficient from an emissions standpoint.
800%. If water is that remarkably cheap and that drastically more sustainable for the planet, why aren't we shipping everything by barge? Why don't we build massive canal networks? Are we just hopelessly addicted to two-day shipping?
If we connect this to the bigger picture, speed in logistics is not just about human impatience. In the modern supply chain, speed is actually an inventory reduction strategy.
Wait, how does speed reduce inventory?
Let's say you decide to be highly sustainable and ship your product by barge, and it takes 4 weeks for your goods to arrive. Because that transit lead time is so long and the risk of weather delays on the water is high, you have to hold 4 to 6 weeks of extra safety stock in your destination warehouse.
Just to ensure you don't run out while you're waiting for the next slow barge to arrive.
Exactly. And holding that massive amount of physical inventory ties up huge amounts of your company's working capital. If you fly the goods, they arrive tomorrow, you don't need safety stocks at all. The true art of logistics is matching the physical reality of the product, its weight and its value, to the economic reality of the transport mode to achieve that lowest total cost we discussed at the very beginning.
So what does this all mean? It means that logistics isn't just about loading trucks and stacking cardboard boxes. It is a massive, globally integrated web of constant, high-stakes trade-offs.
Absolutely.
To succeed in this space, you have to balance the hyper-focused expertise of 3PLs against the overarching general contractor control of 4PLs. You have to mathematically calculate whether the customer service boost of having 10 decentralized urban warehouses actually outweighs the immense financial burden of duplicating your management and safety stock.
It's a constant balancing act.
Yeah, and you have to decide if your product's value density justifies the astronomical cost of an airplane, or if it demands the sluggish sustainability of an ocean freighter. Winning in supply chain means navigating these variables every single day to achieve the exact level of service the customer demands at the absolute lowest total cost.
Exactly. And that leaves us with a final, very important question to consider regarding the future of this invisible machine.
I'm listening.
Right now, the entire modern logistics system is optimized to replace physical inventory with digital information and raw, unadulterated speed. We use fast transport modes and predictive data to enable just-in-time delivery, keeping warehouses as lean as possible.
Which makes sense financially.
It does, but we are rapidly reaching the physical limits of our global infrastructure. Ocean ports are chronically congested, railway networks are aging, and pilot and truck driver shortages are becoming a permanent reality. Furthermore, the immense environmental costs of this hyper-fast, carbon-heavy shipping model are becoming impossible for regulators and consumers to ignore.
Oh, wow, yeah. The bill is coming due.
It is. So as those physical and environmental walls close in, will the supply chains of the future be forced to reverse this decades-long trend? Will we have to return to a world of massive, localized anticipation inventories moving slowly and efficiently by rail and water, fundamentally ending the era of just-in-time delivery?
That is a profound shift to think about. We've spent 40 years building a fast, light supply chain, and we might be heading back to a slow, heavy one.
It's entirely possible.
Well, thank you for joining us on this deep dive. Next time a package arrives at your front door or you see a fully stocked shelf at the grocery store, take a moment to appreciate the thousands of miles, the robotic choreography, the massive ships, and the incredible balancing act of trade-offs that made it happen without you ever noticing. Keep questioning how the world around you actually moves.